The large block in the middle of the periodic table is home to the transition metals, including well-known metals such as iron, copper, gold, and mercury. Other more unusual transition metals include scandium, niobium, and ruthenium. They all have similar physical and chemical properties. Transition metals are much less reactive than the metals in groups 1 and 2, so in general the transition metals are more useful. But all metals have the following physical properties in common. Metals are hard. Many tools are made from metals because of their hardness. Metals are shiny, so they're widely used to make decorative items. Metals are malleable. They can be hammered and bent into different shapes, resulting in these fine items of jewellery. Or this huge modern sculpture. Metals are ductile. They can be drawn into wires, again making them useful in jewellery and construction. Metals are strong. The metals in these bridges have good tensile strength for supporting heavy loads. Metals conduct heat. Thermal images of a saucepan on a hot plate show that heat energy is easily conducted through the metal pan. Metals also conduct electricity. Place any metal in a circuit and it'll allow electricity to flow. Most metals have high melting and boiling points. A tungsten filament has a melting point of over 3,000 degrees Celsius. Metals are also sonorous. This means they produce a sound when struck. Alloys containing the transition metals copper, nickel and zinc are used in coin production. A mixture of metals is used because it's stronger and harder than pure metal. What other properties make metals suitable for minting coins? Some transition metals can be used as catalysts to speed up chemical reactions. The transition metals platinum and rhodium are the catalysts in catalytic converters. These speed up the chemical reaction between carbon monoxide and nitrogen monoxide produced in engines. These polluting gases combine to make carbon dioxide and nitrogen. This is how a catalytic converter reduces the emission of pollutants. The solutions of transition metal compounds are often very colourful. Because of their bright colours, transition metal compounds are used to produce the vivid colours in pottery glazes. They add colour to the surface of the clay. To show the range of glazes, this potter is making some test samples. First, the fresh clay is moulded into shape. It's then fired to dry it out and prepare it for glazing. Next, the clay shapes can be dipped into glaze mixtures. These contain different transition metal compounds. The glaze coats the surface of the clay. Finally, the shapes are placed in a kiln for a second time and heated to a very high temperature. The result is an array of different colours provided by the compounds of different transition metals. And different compounds produce different colours depending on the type of clay that's used.